Okay, so system of equations just means we have two or more equations using the same variables. So right now at the beginning, we're just going to focus on two equations. As we get farther into the unit, we'll have three equations and three variables. So I don't think you guys have seen that before. But for the moment, we're just going to do two equations with two variables. Okay, now, solution to a system. All this says is a set of values for the variables that make all the equations true. And then I just have you can solve by graphing, and it's just the points or the point where the graphs intersect. So that's what you're looking for. If I scooch this up here a little bit, it doesn't say what is the solution. It just says tell me how many solutions that you have. So don't actually look at the, like, what are the coordinates of the point. It's not like that. It's just like, how many solutions do you see to the system that's graphed here? So in my first lovely picture, we just have, like, I have a line here and I have a line here. If that set was my system, how many solutions does that system have? Just one, right? You can just that one point right there. Now, my second system has a lovely parabola here, and then it also has a line. How many solutions do you see for that system? Okay. This one has 2. So just any point or points they have in common. So it's not asking you what they are, just how many. So this one has 2 different points where that line intersects that parabola. What about the third system? I've got 2 lines graphed here. How many solutions do you see there? How many points do they have in common? No solution. They don't run into each other, right? So these are parallel lines. This is no solution. Okay. Does anybody have any questions? Now, I'm going to have you guys actually graph these and tell me the actual solution. So we're just going to graph some lines in example 2 here. So for the very first one, just however you want to do it, I'm going to graph mine in 2 different colors, but it's just in slope-intercept form. The first equation is 1/2 x plus 3. So I'm going to start at 3 and just go up 1 over 2. And usually when I do these, I maybe don't play connect the dots. I just kind of draw some points in, and then I draw the other line because I kind of have to get a specific point here that they're going to have in common, so I don't really know where that's going to be yet. So let me start to graph the other one. So I have negative 1/4 x minus 3. So I'm going to go down 1 over 4. And as I do that, I can kind of tell I'm going the wrong direction in terms of where they're going to intersect. So for both of these cases, I'm actually going to kind of go backwards. So I'm going to go back up to my first one, and I'm going to go down 1 over 2 to the left. This is still a positive direction, but I'm just going to graph a couple points here. And for this one, I'm going to go backwards too. So I'm going to go up 1 and left 4. And it takes me all the way back over here. Oh, I didn't do a good job graphing that line. Can you guys tell what point those 2 lines have in common? Like, what are the coordinates of the point? -8, -1, she says. Exactly right. Okay. Now, I'm going to slide down underneath here just for a second. So I'm going to give you, there's some vocabulary terms that go with this, but these 2 lines intersect each other, right? This is called an independent system. And if you have an independent system, that means your 2 lines are intersecting. Now, the only requirement for this to happen is that they would have different slopes. If your 2 lines have different slopes, you will automatically be an independent system. They will intersect somewhere. It might not be in the graph picture that you have, but if you have different slopes, independent, intersecting lines, and that will always be a situation where you have one solution. Just one point. If you have 2 lines, they'll only have 1 point in common if they intersect. Now, my system in the middle here, the first equation is nice for us because it's already in slope-intercept form. So I got y equals -2x minus 1. So I'm just going to go down to -1. And then I'm going to go down 2 over 1, down 2 over 1. Just draw a couple points. Now, the next equation is in standard form. You guys want to graph that from standard form? Like do intercepts on that? Anybody tell me why intercepts would maybe be maybe a little bit of an annoying idea for that section? Right. So what would you do to graph that? What would you do to graph this? Yeah, okay, how would you do it? Perfect. Okay, we're just going to subtract the 2x, right? All right, so you get y equals negative 2x, and I'll just slide the 5 over. I always just, if I move something with an x to the other side, just write it right after the equal sign. If there's something already there, like we have a positive 5, just slide it over, because then it'll be in slope-intercept form. Now, you guys can probably see right immediately from looking at that we're going to start at 5, and then we're going to go down 2 over 1. But you can see these guys have the same slope. They have different y-intercepts. So what can you tell me about these two lines? If I have the same slope and a different y-intercept, what do I have? They're parallel for sure. Okay, so in terms of a solution here, they don't run into each other, so this is no solution. Now, this is going to happen when you have the same slope, but you have a different y-intercept. When you have that, there's a vocabulary term for this system. It's called inconsistent. So anytime you got parallel lines, it's called an independent system. Like I said, the lines will be parallel. And there is, in this situation, never a solution. So there will not be a solution. Inconsistent is parallel lines, no solution. All right, now the last one. Again, I've got a nice, like, we're in slope-intercept form, negative 1/3 x plus 3. So let me just, I'm going to start at 3 and go down 1 over 3 to the right, graph a couple points. Now, intercepts would not be bad for this last one because 18 is divisible by both 2 and 6, or negative 2 and negative 6. So you can do that if you want. I might recommend like what we did on the last question though. I would probably put it in slope-intercept form. So what I would do is add the 2x real quick. And my goal there is going to be to put y by itself on one side. And I'm going to write the 2x right after the equal sign and just slide that negative 18 over to the side. Then it'll look more like standard form, or sorry, slope-intercept form. Now, be careful with this. When you get y alone, you have to divide by 6, right? Don't forget, you have to do that to all 3 parts of this equation. You have to divide every single thing by 6. So, who can... raise your hand and tell me, what is that going to simplify to be on that side? Hayden, what do you think? Yes. And what would your y-intercept be? Plus 3. Okay. Now, do you all see? Like, this wasn't immediately obvious to me when I started this, but these two equations actually end up being exactly the same. So if I had graphed this first one, right, I'm just going to play connect the dots real quick. The other line would literally be exactly the same, so it would be graphed like on top of it. How many solutions do you have in that situation? Do you know? Does anybody remember? Infinite. They literally, like, a line has an infinite number of points. I know when we plot and we do like slope, you know, we just plot a couple points, but there's points all along in between here, not with nice and x and y values, right? But they have every single point in common. The line goes left and right forever to negative infinity and positive infinity. There's an infinite number of points here, so that's why they're going to say this has infinite. I'm just going to use infinite solutions. Just using an infinity symbol there. Infinite solutions. Now, the special name for this one, this is called dependent. And I don't know why, I just kind of remember this, like the lines depend on each other because they're graphed on top of each other. I don't know if that helps anybody. But dependent system means you have the same line. Now, different from the last one, this ends up being the same slope and the same y-intercept, which immediately was not evident when we looked at that question because we had one in standard form, one slope-intercept form. So you had to maybe do a little manipulation with algebra to see that. But that situation, dependent, same line for both, that has infinite solutions every time. Those are the only three options if you have two lines in your system. Independent, inconsistent, or dependent. One solution if they intersect, no solution if they're parallel, and infinite solutions if they are exactly the same line. Okay. Now, I'm not going to give you a graph on this. I'm just going to ask you this question. Both of these equations are in standard form in the system. It says, is the point 4, 2 a solution to the system? And then it gives me x plus 2y equals 8. 2x minus y equals 6. Does anybody know, like if I don't give you a graph or anything, how could you decide if 4, 2 was the solution to the system? Like how would I go about doing that?
Take the y-intercept and then find the coordinates of that and then put the slope and really keep on adding on to that.
Say that one more time?
So like find the y-intercept and keep on adding on to the slope.
We could do that to see if it went through that point. Yes, you could do that. Does anybody think it's something different? Yeah, that's what I was thinking. That might be just a teeny tiny bit fast. Like you could put them on the graph and see that. It might be just a tiny bit faster. You just plug the values in. So like this would be your x and this would be your y. So if I did that first equation and basically just replace x with the number, this just might save you some time, especially if you don't have a graph. And in for y I'd put 2. Just see if it's true. Just see if it's true. So here, totally true. So that satisfies the first equation. I just plug the x coordinate in for x, the y coordinate in for y. Now, if it's a true statement, it has to work for both. If it works for one but not the other, your answer would be no. If it doesn't work for either one, your answer would be no. So if I do the second equation, I have 2 times my x value, which is 4, minus my y value, which I'm subbing in 2, is supposed to be equal to 6. We're seeing if this is true or not. So I get 8 minus 2. 8 minus 2 is 6. So that means that point satisfies both of those lovely equations. And if you did want to put them on a graph and go ahead and do that, you could check it that way too. That would be totally fine. I just didn't have a graph on this lovely picture. Is anybody having a question? Just has to satisfy both. If one or both of them it doesn't satisfy, then your answer would be no. In this case, I didn't even write my answer. It would be yes, because it works for both. Makes both equations true. All right, now, these two guys, just a little review of how to graph horizontal and vertical lines. So, if I have y equals 4, remember, slope is 0. I call it horizontal to help me remember. Here is the point, like 0, 4, 1, 4, 2, 4, 3, 4. It is always, if you have y equals a number, just a nice, beautiful horizontal line. All those y coordinates are the same. The x coordinates change as you go left and right, but all the y coordinates are 4. Now, if you have x, I call it vertexal to help me remember it. So like a point where x is -3, maybe -3, 0. Here's -3, 1, -3, 2. It always messes people up, but this is a vertical line. So all those x coordinates are -3. What is the solution? Who can raise your hand and tell me to that system of equations? What point? Because we can see they intersect. What point do they have in common? Yes, it's literally just the x coordinate and the y coordinate of the two. Can you guys tell me the answer to the second system I've got here without doing it? Liam, what do you think? For sure. Why? Exactly. These guys are both x's, right? So x is -2, nice vertexal line at -2. X is 5, nice vertexal line at 5. All those x coordinates are 5. Those are parallel. Now this would be a situation where when we have an x equals, remember this has no slope, they both have no slope, they don't have the same x value. It's possible they could be the same line, but these are definitely parallel because those x values are different, so no solution if they don't run into each other. All right, where is the line x equals 0? It is the y-axis. All right, so I know that always messes people up, but all the x-coordinates are 0. Now, we're going to see, actually, does anybody know the answer to this without graphing it? Liam, what do you think? Yes, how'd you know? Exactly, exactly. The other thing you could do here, especially if you have a plain linear equation, you could actually just plug in the x value to this equation and get that, or you can do it on the graph. It's just another way to think about it. But if you know x has to be 0, you could plug 0 into the second equation to figure that out, or you could be perfect and put it on the graph here. Let's see, I'm going to go down 5/2. So if I need a visual for this, and you can see that that intercept is going to be 0, 4. Okay, now we're not going to, the last equation, I have a parabola already graphed for you. We're going to do a whole unit on quadratics and graphing parabolas. Actually, that's our next unit. So if there's any question that has something like that, I'll either put it on there for you, or we'll have you use the graphing calculator or Desmos or something to look at it. But you won't have to graph any, bless you, parabolas by hand. But the other graph, which is y equals -2, is not on this one. So let's just draw a nice horizontal line. Oh no. Let's pretend Miss Grody's not an idiot, and let's make this y equals -1, not -2, because otherwise we're not going to go through nice points. I'm really sorry. Yeah, the other points were not on nice. I'm not going to give you anything that's like a weird value unless we're doing the calculator with it. That's my fault. Pretend that said y equals -1. All right, how many solutions do I have here? 2, right? You can see 2 spots. And when we move that to the correct equation, my apologies, we actually have 2 answers to this. So it looks like -3, -1, and +1, -1. So it is possible to have 2 answers. Not if you have a line, like 2 lines, but if we have a parabola and a line, you could have more than 1 answer. Is anybody having a question? Okay. I actually have the homework for you guys on the lovely Math Excel. So if you have your new homework packet, I don't know if you'll need it or not, but the first couple pages, they're just scrap paper, so you guys can use that. And it's going to be